Hi everyone, welcome back. This is the first recording, so we will focus on Unit 1, where we examine intelligence as a construct and intelligence testing. So first we'll look at the learning outcomes. We'll define intelligence and discuss the nature of reliability and validity in testing. And then we'll summarize the contributions of Sir Galton and those of Drs. Binet, Terman, Weschler, Cattell, Sternberg, and Howard to the evolution of intelligence testing. So let's look at intelligence as a construct. So intelligence describes a mental capability that involves our ability to reason, to plan, to solve complex problems, to think abstractly, to comprehend complex ideas, to learn quickly, and to learn from experience. So all these descriptors align with what appears on the slide. So it's our ability to acquire, so learn from experience, to acquire new information. It's our ability to comprehend complex information, so to process the information, to recall and apply information to problems, to plan and solve problems. Part of that involves thinking abstractly and ability to reason, and it's also our ability to adapt to new situations. So that is congruent with our ability to learn from experience. So let's look at important concepts in psychological testing. So the first one we'll cover is reliability. So reliability refers to the test's consistency, meaning that repeated measurements should yield reasonably similar results. So reliability estimates are based on correlation coefficients. Correlation coefficient is something we learned in Psyc 1001 DC. So it measures the degree of the relationship between two variables. So both the direction of the relationship, if the change in scores of one variable rise, do the scores in the other variable also rise? So that would be a positive correlation. And also the strength of the relationship. Okay, so an example would be, is there any relationship between cigarette smoking and life expectancy? Okay, so that's an example that goes back to Psych 1001 DC. So looking at the relationship between two variables. So here, the correlation that would be measured would be between the scores obtained on a test, on a participant undergoing a test for intelligence, for instance, and then being retested. And those scores would be correlated with the ones obtained on the original test. So retest reliability would capture the level to which, the degree to which the scores from test 1 to test 2 are consistent. Okay, so they should yield, if a person is tested on day 1 and then tested again on day 2, their test scores or their testing should yield similar results. Another type of reliability is inter-rater reliability. So this is where there are two sets of scores obtained from two administrators of the same test, and they're correlated too. So the closer the correlation coefficient is to 1, the more reliable the test. Okay, so if a test is consistent, then it wouldn't be impacted by the person administering the test. The results would not be impacting by the person administering. Instead, regardless of who is administering the test, the results should be, the testing should yield comparable, similar results. Okay, and then we have internal consistency. So internal consistency refers to the extent to which single items within the test measure the same construct. So this reliability it measures the degree of agreement between among different test items. So if a person is being tested on a test, and there are a set of items that are meant to measure their verbal ability. The person's response, if those items have internal consistency, and a person scores at, let's say, 90%, receives a 90% on one of the items for verbal abilities, then they should have the same comparable performance on other items if they are that are testing for verbal ability, if there is internal consistency within the test. Okay, so if there are multiple items that test for the same intelligence ability, such as verbal competence, then the results, the person's test results on those items should be similar. Okay? Construct of validity. So validity describes the degree to which a test accurately measures what it purports to measure. To what extent is this test a reflection of the particular domain that it is meant to measure? So to what extent is this intelligence test, this particular intelligence test, a reflection of the particular domain, in this case intelligence, which it is meant to measure? So the first form of validity is constructive validity. And constructive validity is the extent to which there is evidence that a test measures a particular hypothetical construct. So in this case, whatever the test is, there is evidence for it that it measures intelligence. Okay? Whereas predictive validity measures how well one measure predicts an outcome for another measure. Okay, so a test of this type of validity is important, because if it is useful, then it's going to predict performance or behavior in another situation. So an example of this would be scholastic aptitude tests. So those are given in the United States, they're given in high schools, and they're used to see if they predict, or if they are accurate predictors of academic success in post-secondary institutions like colleges and universities. Okay, is an accurate measure of the hypothetical construct of intelligence. Does it have predictive validity? Is it able to is it a measure that predicts an outcome for another measure? So here in this case it would be, is this measure of intelligence, of the hypothetical construct of intelligence, is this test able to predict an outcome on another measure, or for another situation? Okay, so in particular, can the SAT scores predict academic success in university? Okay, so these are the two constructs that are very important to know when it comes to psychological testing. Now let's look at the evolution of intelligence testing. So now we're going to look at the contributions of different scholars in the area of intelligence and intelligence testing. So the first scholar whose work we'll examine is Sir Francis Galton, who's actually the cousin of Charles Darwin. So he placed particular emphasis on natural selection with a focus on intelligence. And so he put forth a notion that success runs in families because intelligence is a trait that is inherited. Much like physical traits are inherited, so are mental traits. And so he argued that intelligence is a trait that is inherited, and he developed a very crude mental abilities test based on sensory acuity. So he measured reaction speed, muscular strength, and sensory acuity, the latter being a measure of mental ability. And so his position was that intelligence is a mental trait that is inherited. Okay, so this is emphasized in his main argument, being that mental and physical features are equally inherited. The next scholar we're going to look at is Alfred Binet and Theodore Simon. And so they published the first intelligence test in 1905. And this is a test that was designed to single out young students who were in need of special training. And so the test expressed the child's scores in terms of mental age. So for example, a 4-year-old child with a mental age of a 6-year-old child performed like the average 6-year-old. Okay, so there's chronological age that is taken into account. So that's the child's chronological age. But the mental age is the equivalent, or the equivalent chronological age that a child reaches based on his performance on the intelligence test. And so they developed the intelligence quotient test, Alfred Binet and Theodore Simon. And here what happens is that, so the person is compared to their same aged peer group, okay? And if their performance is comparable to that of their peer group, then they have the mental age, their mental age matches their chronological age. Okay, so here we have how the intelligence quotient was measured. Okay, so the first two lines describe how Alfred Binet and Theodore Simon measured the children's mental age. So if a child, for instance, who is 6 years of age, so if a 6-year-old child has the mental age of a 6-year-old child, age peers, here the child is comparing at the same level as his or her same age peers, 6 years. So their mental age is 6 years. But if you look at a child who is 9 years of age, but is performing at the level of 6-year-olds, then their mental age is 6 years of age. So then if you have a child who is 12 years old and performing at the level of 9-year-old, the average 9-year-old child, then their mental age is 9 years. And if you have a child who is 9 years old but performing at a level of a 12-year-old child, or the average 12-year-old child, then their mental age exceeds or surpasses their chronological age. They're 9 years old, but they're performing at the level of the average 12-year-old. Okay, and I say average because these test scores are compared to the cohort, the age cohort as a whole. It's not one single child of that age, but it's the average of all the children of that age. Okay, and here if we look at the bottom line, so that's the work. So if we go over how Lewis Terman transformed the intelligence the measure of intelligence, is that he introduced the intelligence quotient. So the intelligence quotient is that fraction, is the mental age over the chronological age multiplied by 100. So it's mental age over chronological age multiplied by 100. And this is going to give the person's IQ score and make it possible to compare to other individuals. What this entailed is a standardization of the individual IQ scores. So standardization describes two important constructs. One is a standard procedure that is followed to administer testing and to record test scores. So it doesn't matter where the test is administered or by whom. There are always standards that are followed, making sure that they're going to be very reliable and very consistent. Okay, and so the standardization of individuals' IQ scores is another facet of standardization. And so this involves the transformation of the raw scores onto this normal distribution, this bell-shaped curve. And so IQ scores, or the IQ score distribution, is one psychological phenomenon that falls under a normal distribution or a bell-shaped curve. Okay, so if we look at IQ scores are plotted on the x-axis, and that's the raw score. And you can see that it has this, it falls under a normal distribution. So first characteristic being that they are symmetrical. If you divide the bell curve into two equal halves, one will be the mirror reflection of the other. So if you take the bell curve and you divide it in the middle, which is the mode, the median, and the mean, the mode, and the median, that falls under the same point. If you take that curve and you fold it into two, you're going to have two symmetrical halves. Okay, so the average IQ score is 100. A score of 100 has the highest frequency. It is the score that appears most frequently in the record of individual IQ scores. Okay. There are important characteristics. Here we have, for 68% of the population, their IQ scores fall between 85 and 115 points. So those are the raw scores. Another important characteristic is that the average distance from the mean, which is the standard deviation. Remember, we went over standard deviation in Psych 1001 DC. It's the average distance from the mean. So if you take each individual score and you measure its distance from the mean, and then you calculate the average of all the distances from the mean, that's the standard deviation. And here, in this case, in the case of IQ scores, the standard deviation is 15 points. So the average distance from the mean in a population of scores is 15 points. Okay? And so if you look at the raw scores that the range from 85 to 115, 68% of the population fall within that range. And that range also represents -1 to +1 standard deviation from the mean. So those who score at 85 have a raw score of 85 points, they are at -1 standard deviation from the mean. So this standardization helps to express the person's raw score in terms of distance from the mean. How far away from the means is this person's score? Is it close to the mean? Is it within 1 standard deviation? Or is it like 90 points? Or is it at 1 standard deviation? Is it 85 points? Or is it below? Is it even greater than 1 standard deviation? Okay. 95% of human IQ scores fall between -2 standard deviations from the mean to +2 standard deviations from the mean. And then if you take the extremes of the normal distribution, so that's another 2.13% in the lower end, okay? And then you also take the 2.13% in the higher end, okay? Then that becomes the whole distribution. That's 100%. 100% of the scores fall between that entire range, -3 standard deviation to +3 standard deviations from the mean. So again, the standardization looks at a way to express a person's IQ scores in terms of how they are situated relative to other. So here, it's very interesting. So these are if you took this distribution and you separate it into two equal halves, they are symmetric, okay, so they are a mirror reflection of one another, the two halves. They are unimodal, so there's only one mode. There's only one mode. The most frequent score is 100. There's one mode. They're mean, median, and mode. Remember we covered those in Intro Psych. In Psych 1001 DC are all equal. So the mean is 100 IQ points. The mode, the most frequent score, is 100 points. So that's the mode. And the median. So the median is if you take the range of scores, you take all the scores, you plot them, and you take the middle score that allows you to fold, like if you were to have one half of all the scores below that point and the other half of all the scores above that point. What is that point? That's the median, and it's 100 points. So the mean, median, and mode of a normal distribution are all equal. Okay, and again, the left side, it's all centered around that 100 score, and the left and right side of the curve are a mirror image of one another. Okay.